Hey makers, welcome back to Hub360 Embedded Sphere, your favorite stop for IoT and embedded projects. In today's tutorial, we'll be building a blink-controlled robotic arm using ESP32. This robotic arm can move its base, lift its shoulders, bend its elbows, and open or close its gripper, all controlled wirelessly from your smartphone through the Blink IoT app. Let's dive in. Components used: we'll be using an ESP32 development board, 4 servo motors for the base, shoulder, elbow and gripper, jumper wires, breadboard, a 7.4 volt Lion battery, a buck converter, and a smartphone with Blink IoT app. Now let's move to the connections. First, connect the buck converter to the Lion battery. First, connect the V-in of the buck converter to the battery's positive wire. Next, connect the ground of the buck converter to the battery's negative wire. Next, connect the V out of the buck converter to the 5 volts of the servos. Now connect the output negative of the buck converter to the common ground shared with ESP32 and servos. Now let's move to the servos to ESP32 connections. First, we are going to connect the base servo. Connect the signal, which is the orange wire, to GPIO12. Next, connect the VCC pin to the 5 volts from the buck converter. Next, connect the ground of the servo to the common ground. Now let's move to the shoulder servo. We'll be connecting the signal pin to GPIO5. Next, we'll connect the VCC pin to 5 volts from the buck converter. Next, we'll connect the ground to the common ground. Now let's move to the elbow servo. First, we'll connect the signal pin to GPIO16. Next, connect the VCC to 5 volts from buck converter. Next, connect the ground to common ground. Now we'll move to the gripper servo. First, you connect the signal pin to GPIO13. Next, connect the VCC pin to 5 volts from the buck converter. And finally, we'll connect the ground to common ground. Important note: Always power your servos with a separate 5-volt supply. When connected directly from the ESP32, 5-volt pin can cause brownouts or random resets. Connect all grounds together, that's the ESP32, the external supply, and the servo ground for stable control. Code explanation. Let's break it down step by step. The Blink setup. This defines your Blink template ID, project name, and auth token, all generated from your Blink IoT dashboard. This links your ESP32 project to your Blink account. The Wi-Fi setup. ESP32 connects to your Wi-Fi network using these credentials, allowing it to communicate with the Blink cloud server. Servo configuration. We attach 4 servos to their respective pins. Each servo is controlled using ESP32 servo library, which allows smooth PWM control for accurate positioning. The initial setup. Each servo is initialized and positioned at neutral angles, that's 90 degrees, so the arm starts in a balanced and safe position. Next, go to the Blink controls. Each servo movement is mapped to a virtual pin V1 to V8 in the Blink app. Buttons in the app send values 1 or 0 to these pins, and the ESP32 moves the servos accordingly. For example, the base left and right should be assigned to V1 and V2. The shoulder up and down should be assigned to V3 and V4. The elbow up and down should be assigned to V5 and V6, while the gripper open and close should be assigned to V7 and V8. This prevents sudden jerks and makes the movement smooth and controlled. The main loop. The Blink.run. This continuously listens for commands from your smartphone via the Blink app and updates servo positions in real time. How it works. Every time you tap a button in the Blink app, a signal is sent through Wi-Fi to the Blink cloud, then to your ESP32. The ESP32 receives this signal and adjusts the servo position slightly, giving you precise manual control over each joint. It's like having a virtual joystick in your pocket. And that's it. You have successfully built a Wi-Fi controlled robotic arm using ESP32 and Blink. In this tutorial, you have learned how to connect multiple servos to the ESP32, control motion smoothly using the Blink IoT app, design a responsive robotic system with cloud-based control. All components used in this project are available at hub360.com.ng. Like this video if it helped. Subscribe so you don't miss part 2. Until next time, keep building, keep innovating. This is Hub360 Embedded Sphere, helping you bring your ideas to life.